today we're going to be talking about Charles's Law again. We had a video yesterday, and we did some problems yesterday, and so now that you have these sample problems to do, and I'm going to set the timer for 10 minutes, and that's how long I've got to help you, and then the rest of it will be on for you, okay? So we're going to go ahead and get started. So the first thing that we're going to do is we're going to look at the problem. Remember what I said. I usually like to have two colored markers so that I can highlight the different ones so I can keep track of what I have. So the first thing that we're going to do is we're going to read it. And so I'm going to try to make us enough room where I can have the paper in my ISM book too, so that you can see both as we go through. We'll see. Okay, so this says calculate the decrease of temperature of a 6.0 liter at 20 degrees Celsius is compressed to 4.0 liters. Okay, so the first thing we're going to look at is we're going to write down our variables. So remember, volume is in liters, right? Here's our formula for number, and this is number 5. So we have V1 over T1 equals V2 over T2 is the gas law. But remember, the first thing we're going to do is we're going to do the crisscross, which is V1 T2 equals V2 T1. Okay? So then the next thing we're going to do is we're going to write down a formula. So I have a V1 and I have a T1. I have a V2 and a T2, and I'm doing it based on this up here because remember we're going to plug and chug it back again, or we can use this one as a plug and chug too. Either way will work. So the first volume is 6.00 liters. We have a 20 degrees Celsius temperature, and then our final volume is 4.0 liters. We have one conversion, which is our 20 plus 273, right? Let's look back. Yep, 273. That is 293 degrees Kelvin. Okay, so now what we're going to do is now we're going to put our equation in to where we have the unknown by itself. We're looking for T2, right? So that's V1 T2 equals V2 T1. We're going to divide both sides by V1 to get T2 by itself. And then we're going to plug in our number. So V2 is 4.0 liters. T1 is 293 Kelvin. We're going to multiply those. And we're going to divide that by our liters, which is 4.0, which is V1, 6.00 liters. So for that, we're going to do our alpha Y inner. We're going to do we're going to do open bracket 4.0 times 293 and then over 6 liters, which says that is 1953333 repeating. Okay, so what I'm going to do is I'm going to go ahead and put it back in this equation. So my V2 is 4.0, and I'm going to divide that by my second answer, and I'm going to get 0.024077857. Okay, so then I'm going to take my 6.00 and I'm going to divide that by 293. I get the same answer, so that's my check answer. So over here, I'm going to say that my T2 equals, and we have 193 plus 3 repeating, so I'm going to say 195, and that is Kelvin. And my check answer is 0.024077857. Okay, so then the next one says a container contains 5 liters of gas. It's collected by 100 degrees Kelvin, and then it is allowed to expand on 20 liters. What is the new temperature? And as required in the gas law. So for number 6, V1 T1, V2 T2, right? we're going to go and do our variables. V1, T1, V2, T2. So our first volume is 5.00 liters. Our second volume is 20.0 liters. Our first temperature is 100 degrees Kelvin. So since this is Kelvin, we don't have to do any kind of plus 273 for that at all, do we? So then we're looking for T2 again, aren't we? So we have it up here already, so I'm just going to do that. T2 equals V2 T1 over V1. Plug it in. My V2 is 20 liters. My temperature one is 100 Kelvin. And my volume is 5.00 liters. So then I'm going to take my calculator and I'm going to do alpha y, enter again. I'm going to do open bracket 20 and then this 100 down 5.00, and that tells me it's 400. So I'm going to go ahead and I'm going to take my 20. I'm going to divide it by my second answer, and I get 0.05. Then I'm going to go ahead and take my 5.00 divided by 100, and I got 0.05 again. So 0.05 is my check number. And my answer for T2 equals 400 degrees Kelvin. Now, the next one that we have, we're going to have to do something special with it. All right, so here's the problem. We have milliliters here, and we have to have these into liters. So it says a gas occupies 900 milliliters with a temperature of 27 degrees Celsius, and it also has a temperature of 132 Celsius. So we've got a lot of work to do on here. So the first thing that we're going to do is our V1 T1 equals V2 T2. So we're going to do V1 T1, V2 T2. So our first volume is 900 milliliters. But we're going to take our 900 milliliters and we're going to have to convert those to liters, right? And there is 1,000 milliliters in 1 liter. So 900, open bracket, alpha y, enter, 1 over 1,000, close bracket, and that is 9 divided by 10, which is 0.9. So this is 0.9 liters, okay? And then it says 27 degrees, 27 plus 273, which is 300 Kelvin. So I converted it. 132 was my second one. 132 plus 273, which is 405 Kelvin. And so now I'm looking for V2 this time, okay? So I'm going to put it over here on this side so I don't get confused. So I'm just going to put it over here. So if I have V1 T2 equals V2 T2, right? I am looking for V2, so I'm going to divide both sides by T2. There we go. And then this is where my answer is. So I'm going to take V1, which my V1 is 0.9 liters. I'm going to times that oh, I'm doing it wrong. Here I go again. So let's do that again. So V1 T1 and then V2 T2, and if I'm crisscrossing, that would be V1 T2, V2 T1. I'm looking for V2. I need to divide both sides by T1. Okay, so it's V1 T2 by T1. So V1 is 0.9 liters. I'm going to multiply that by 405 Kelvin, and I'm going to divide that by 300 Kelvin. So let's see what we got. Alpha y, enter, open bracket, 0.9, close bracket, open bracket, 405, close bracket, down, and it's 300. And that's going to give me 1.215. So if I take that second answer, and then I divide that by 405, I get 0.003. If I take this next answer and divide it by 300, I get 0.003. So my check answer is 0.003, and this is my check answer. And the answer that I'm looking for here, which is my volume 2, which is equal to 1.2, and we're going to call that liters. Okay? And so that means I'm going to leave you with the last one, and then do that one, take a picture, and submit it. Have a good day.